Okay, I've been asked about this question from page 126 of the core book. It's very highly unlikely this will be a question that will come to you on a I paper, but I'll go through it anyway just to kind of show you what it means. So you expand the sum of the first k numbers from k is 1 to n. So if k is 1, k is 2, k is 3, k is 4, k is all the way up to n. So that's what it looks like. So that's what that means. K is 1 to n. K changes from 1, 2, 3, 4, 5, 6, 7, 8, 9 all the way up to a number n, and that there means sum of. So you add them all up. B says add the two. Oh no, sorry. And then write the expression again underneath with the terms in reverse order. So the second last term, the penultimate term would be n minus 1, and the last term would be n. Penultimate last. If you write it in reverse order, you get n plus n minus 1 plus, that would be n minus 2. It would be antepenultimate term of this sequence. That's the not the second last term, but the one before that. La la la. And then that one would be n minus 3. And then up here we'd have plus 2 and then plus 1 because you're writing in just reverse order. Part B then says to add the terms vertically. So add the terms vertically. So vertically means that plus that, that plus that. So 1 plus n, that will be n plus 1. N minus 2 plus n minus 1, or n minus 1 plus 2, that term plus that term, would be again n plus 1. If you think about it, what you're doing there is you're doing 2 plus n minus 1, which is n plus 1. That term there, 3 plus n minus 2, would also be n plus 1. And so you'd end up, that there would be the same thing. Look, n minus 1 plus 2 would be n plus 1. That one there would be n plus 1. You end up with a bunch of n plus 1s, you see. How many n plus 1s? It says add the terms vertically and hence write an expression for the sum Sn of the first n integers. So that is the first n integers. Integers meaning positive whole numbers. So that is the sum of the first n terms. But we've got the same thing written twice. So with the same thing written twice, how many n plus 1s have we got? Here we've got n. There's n lots of them, and they're n plus 1s. So we've got n lots of n plus 1 as that entire sum there. That entire sum happens to be 2 lots of the sum of the first n integers. That's 2 lots of it, see? Why is it 2 lots of it? Because you've got one lot of it there and a second lot of it there. So you've added it up once, twice. So that's 2 lots of the thing. And so the sum of the first n integers would actually be the sum of the first n integers, which is that, would be dividing by 2. So n over 2 multiplied by n plus 1. So that's actually in the formula book, I think. It's actually in the formula book. But you've actually proved that formula is the sum of the first n integers. So if you do the sum of the first 10 integers, that's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, it will be the same as 10 divided by 2 brackets 10 plus 1. In other words, 5 times 11, which is 55, which is the same answer as 1 plus 2 plus 3 plus 4 plus 5, 6, etc. It says, hence find A and B such that the sum of k is 1 to n of ak plus b is 8n squared plus 11n for all positive integers. Okay, so I know that the sum of n over 2, n plus 1 for all positive integers, ak plus b. Oh, I see, I get you. I get what it's saying. Let me just snip that and put that down there. I think I know what it's saying. It's saying, let me just put this down here so I can see. What's it doing? So what we're doing is it says the sum of AK plus B. So the sum of AK plus B Well, let's think. Well, n is 1 to n. So b is just a number. So b is a number. You're adding a number to every single term n times. Adding a number every single time. So if I find the sum of k plus 2, well, I'd have an extra 2 for every single one of these entries, an extra 2. And if I had between 1 and n of them, I'd have 2n extra 2s. I'd have n extra 2s. So this sum can be written as the sum of n is 1 to n, ak plus n lots of b, because b is just a number, so you get b every single time, or n times in the entry you get that. Okay, that's separate. And I should say that is separate. How do you separate that? Let me show you. Say separate that. Maybe you do that like that. There you go. So it's that sum separate to NB. And then A lots of something, A lots of the number, again, is just the same as A lots of that sum, n equals 1 to n of k plus NB. So that's how you can separate that. And then you know that that term there is n over 2 n plus 1. So that's your algebra, and you're told that is equal to 8n squared plus 11n. You're told that's equal to 8n squared plus 11n. And the n squared term will come from a n squared. That's your n squared term there. So it'll be a over 2n squared. So a over 2n squared. So a over 2 would have to be 8. So a would be 16. And then your n term would be a over 2n plus b. And you can just work from there and find out what that is. You really do not need that for AI at all. That's an AA and almost an AAHL question. But I think they've just been doing a bit of copying and pasting in the textbook. All right. Ask me in the lesson, but really don't worry about that question. You will not be asked that in AI. Thank you.